Additional information relevant to pipeline explosions. I investigated a pipeline explosion in Cranley near Guildford, Surrey in the UK while employed as an industrial safety officer in the 1960s. The pipe was a ductile steel pipeline with spigot joints and had been buried and reinstated to the end section that was capped off with a dome and blocked with 6 by 6 by 36 inch hardwood skids that were stuck in the trench. It was then tested by pumping high pressure air to a certain level with the intent to hold that pressure for 24 hours to make sure the pipeline did not leak. At a certain pressure, the configuration of the blocked dome end buckled, and there was an explosion and prolonged roar of escaping air that compressed the sandy clay into concrete at the end of the trench and sent one of the wooden skids so high that on return to earth it cut a neat square hole in the tiles of a nearby house, and wood of the nearby house was shattered the concrete path below. I witnessed and photographed the damage with a Polaroid camera and submitted it with the report. Unfortunately, I did not keep a copy, but there is no doubt that this is on record through the court case that about the incident. So this is one of my experiences relative to pipeline bursts. Now, comment about Nord Stream pipeline by yet another expert. No matter who did it, it was deliberate, says Van der Beckel. These pipelines normally simply do not break down, he says. The steel Nord Stream pipelines are 1.6 inches thick with up to another 4.3 inches of concrete wrapped around them. Each of the 100,000 or so sections of the pipeline weighs 24 metric tons, and this picture shows the pipelines actually being laid. And you will see that the pipeline sections are labelled, in this case, with the section number so as to identify this piece of pipe, which is catalogued. If you go to the next picture, you will see this is on the lay barge and it's showing, and these are the gaps where the sacrificial anodes are welded directly to the steel. And this picture is a view of the lay barge itself. This is the pipe coming out into the sea, and you can't see it in the picture, but this arrangement goes right down to the bed, to the seabed, and there are blowers which actually blow the seawater and the sediment away, thus burying the pipe. This is a supply barge, and you can see the crane which is taking the lengths of pipe and depositing them in the bay in which they are welded on the lay barge. This is a picture showing the exact number of this catalogued piece of pipe. This will have another number. This shows a pipe dump where the 100,000 lengths of pipes were stored before the operation began. And this shows the size of the pipes with the guy standing actually on the pipes, and he is probably on the supply barge which is moored alongside the lay barge. You can see that by the seawater there. This is another view showing the lay barge slightly away from the the supply barge slightly away from the lay barge, which is actually laying, and by the labels on here, this is not on the North Sea pipeline, this is on another pipeline. This gives an idea of the size of the project and the degree of expertise required to achieve completion. We must bear in mind, when listening to the opinions of politicians and reporters, they don't understand the immense science and technology involved with the construction of pipelines. This, can you scroll down a bit? This is shown in one of the investigation reports. It is obviously photoshopped, and it shows something which they don't know what it is. The reporter didn't know what this is. Well, it is probably an impressed current anode sledge. And you can tell this because there is a red lead coming in, which will be DC current coming in and DC current completing the surface, and that will be connected to the pipeline. This is connected to the anode. The charges will be discharged from here. They will seek the pipeline to return to complete this circuit. That's how cathodic protection works. This picture is likely to be AI generated or photoshopped, but might be a picture of an impressed current anode sledge designed to discharge DC energy to offshore rigs and pipelines. Right. These are collar sacrificial anodes. This is directly welded to the pipe metal, and this is welded to the collar. Therefore, the electrical circuit can be completed directly from the pipe metal into the sea. Current discharged into the sea by this anode will then go back into the pipeline metal itself if there are any coating faults close by. These are aluminium alloy bracelet anodes that were welded round the steel pipe at selected butt welds. That's where the pipe is welded together. They will then weld these into the whole pipe. They are designed to dissolve and discharge electricity into the sea and cause a potential that will overpower the electromotive force of the corrosion reaction of steel to seawater at any coating faults in the vicinity. This shows the size of the pipes in relation to these two guys who are standing there. These are at a pipe dump, and there were 100,000 of these for each of the pipelines. This picture shows the size of the pipe diameter and helps us to understand the power of the forces involved.